All right, now we're going to look at solving quadratics again, and this is actually just going to go back and cover some of the topics that we've already talked about. Of course, here you're asked to find all solutions. The four things I have listed here is actually the four previous methods we've used for solving quadratics. Back in section 4.5, we did factoring. 4.6 was taking the square root of both sides and completing the square. And then in this section, in 4.7 is when you learned about quadratic formula. So the only difference that you're going to see with these problems is that some of your answers are going to be imaginary, whereas when we did these four methods back previously, we did not encounter any of the solutions that were imaginary. But now that we have learned how to handle those situations with imaginary numbers, now we're going to revisit these processes. All right, so the first one that I have here, and honestly, even though factoring is listed here, as I were going through your homework, I probably wouldn't bother wasting my time trying to factor, because most of them are not going to factor, and you're going to have to use quadratic formula on them anyway. Now, since you have the trinomial, you've got all three terms, you're either going to have to use quadratic formula or complete the square, and it's going to be your choice, so I'm going to guess you're going to want to use quadratic formula. You will have to have your equation set equal to 0 to do quadratic formula. So going through those steps, if you remember, a is going to be the coefficient of the x squared, so that means that a would be -3. B is going to be the coefficient of the x, which would be +1. And C is going to be your constant, which is -3. Okay, now I'm going to rewrite our quadratic formula, so you'll need to have this back in your notes to refer to. Okay, now substituting these values in, I would have -1 plus or minus the square root of 1 squared minus 4 times -3 times -3, and that's divided by 2 times -3. Okay, so now you need to calculate what you have here underneath your radical. Okay, that will give you a value of -35. Okay, now simplifying the square root of -35. Now, there's not a perfect square that will go into 35, but the fact that you've got the negative, remember we do have to take care of simplifying that. You've got to separate the -1 from the 35. So square root of the -1, remember, gives you the I, and then the 35 is just going to be left underneath the radical. Of course, again, when I say your perfect squares, remember that's going to be like 4, 9, 16, 25, 36, that list of numbers, but none of those will go into 36 evenly. So therefore, that would be your answer for this one. Okay, on this one, you're going to, first of all, need to distribute the 2x. So that's going to give you 2x squared minus 6x. Now, in the same step, I'm going to go ahead and add the 5, because you are going to want this to be set equal to 0. Of course, it has to be in order to identify your A, B, and C. Okay, so A is going to be 2, B is going to be -6, and C is going to be equal to +5. All right, so I substituted in my -6. Okay, underneath the radical, I'd have -6 minus 4 times 2 times 5. And then this is all divided by 2 times 5. Okay, so underneath the radical, this is going to give me a value of -4. Okay, so now what we need to do is work on simplifying the square root of -4. Now you would separate the -1. Now, you wouldn't bother breaking down the 4 because the 4 is already a perfect square. So the square root of the 4 is going to give you 2. The square root of the -1 is going to give you I. And of course, you have the 10 that's on your denominator. Now, there is a step of reducing that you can do here, and same thing that I had stressed to you before about reducing with your quadratic formula. So these 3 numbers, since they will all reduce by 2, so 2 will go into 6 3 times, 2 will go into 2 1 time, 2 will go into 10 5 times. So your final answer would be 3 plus or minus 1i divided by 5. Okay? So, like I said, the only difference is having to deal with sometimes your answers coming out to be imaginary, whereas they didn't before. But how you use your quadratic formula, that part has not changed at all. Okay, one more example here. Now, on this one, though, I'm not going to use my quadratic formula, and that's because this is not actually, I mean, if I were to set this equal to 0, and I'm going to write this in pencil, like don't put this in your notes. If I were to set this equal to 0, then this is what I would have, okay? Now, you can definitely use quadratic formula. 2 would be your A. Since you don't have that x to the first power, B would actually be 0 and C would be 24. But anytime that you don't have that middle term where x is just to the first power, then it's actually quicker to use your square root property. So when you're dealing with square root property, you're going to want the constant on the opposite side just like it is here. So since I'm going to go with square root property, I am not going to add the 24. Now, what I would need to do first would be to divide both sides by 2 because I need the x squared to be by itself. So I would have x squared is equal to -12. Okay, so now what you're going to do is take the square root of both sides. So the square root of x squared is x. And then you'll have plus or minus the square root of -12. Now remember square root property, you've got to remember to put the plus minus each time. Now simplifying the square root of -12, you would separate the negative, so that's going to be the -1. Now you would break down the 12 this time because you do have the perfect square of 4 that will go into 12 evenly, and of course it will go 3 times. So you should always be able to multiply these numbers back together to get this. Okay, square root of the 4 is 2. Square root of the -1 gives us I, and then the 3 is left underneath your radical. So there's your answer. So same square root property we did before, same quadratic formula we did before. It's just a lot of these quadratics are going to produce imaginary numbers now that you know how to deal with that.